Hello everybody, my name is Boris and we are talking about turning kernels into threads still, and in previous cases we talked about one-dimensional array of blocks or just one block with one-dimensional array, array of threads inside of it, so 1D for blocks and 1D for threads, because we're using only x-axis. And then we talked about multiple blocks, which is still one-dimensional, and multiple threads inside of it, which is still one dimension. And now we are talking about one block, but with two-dimensional array inside of that block. And that's the name of the game for this topic and for this video. So we are turning kernels into threads, but this time we are using two-dimensional array, which will be seen later. We are defining in general some kernel function which will be turned into multiple threads, and we expecting here that we use x dimension and epsilon dimension for the indexes, and every thread will have own index or coordinates in x and y. And don't forget that this number is representing number of the rows, and this number is representing the number of the columns in the array of threads. So, but this is not two-dimensional array is not defined still yet, because we didn't call the function. That's happening when we call the function with some dimensionality for a given block. How we define block, that's the way we use it later in the kernel calling for turning into threads. So we are expecting indexes on x and y, thread idx, built-in variables, don't forget. And then we have one function to print thread index number for x-axis, and then thread index number for epsilon axis. So we assign these thread indexes for given calling of the thread, which is assigned to that thread. We are giving to these variables, and we are writing them down here. And then we go into another row in writing. Then we will put the pickup of dimensionality of that block. So dot x and dot epsilon, this is of course in x direction, so number of columns will be represented with this built-in variable, and here with block dimension dot epsilon will be represented number of rows. So also notable built-in variables to be let's say shown here is also this one. Maybe we should put here grid dimension.text. So this is the dimensionality of the grid, or how many blocks we have inside of grid. And we can put here epsilon. So we can see and expect that this dimension will be 0, and this one will be 1, because in the calling of this program we will use 1, and that means this is fixed and for x-axis. So for this one we're expecting 1, and for this one, which will be write down because this instructions comes later for every thread, we're expecting the 0. Let's save it and see what's happening. We have main program, of course. Again, we're starting with main program, and then here we inside of the main program we actually define the dimensionality of the one block or threads per block, but put it in 2 dimensions, 6 and 3, for better picking up the stuff from the which we are dealing with. And then we calling that and picking up this let's say struct and putting it here. We expect total number of threads 3 times 6 is 18. So we defining here 6 columns. Don't forget this is x-axis, and 3 rows, and don't forget this is epsilon axis, to be let's say dimensionality of this specific thread block. And that block is now 2D construction, but the grid is 1D, so blocks are we have blocks with a grid with just one element, one block, and thread which is 3 times 6 2D array of threads. So we are talked enough, like Arnold Schwarzenegger said in that movie, enough talk. Let's put it in compiling, and then in execution. Then we will see, do we did things right way. We are compile it, yes, and then we are trying to execute. Okay, main program, let's see what we did here. Okay, grid dimension x, grid dimension epsilon. We don't have grid dimension epsilon. It's not given here. Okay, you can see x-axis, and this is a row, first row, and then we have from 0 to 5 or 6, let's say, indexes, which represents the column index, and then for another row, and for another row. So we have 3 rows, like I said, because this one represents indexes in the sense of rows, and for every of that rows we have 6 column indexes, as you can see. So for 2s, for 1s, and for 0s. Then we have 18 times, I think, skip to another row, as you can see. Then we going to dimensionality 18 times dimensionality of x, which is given here. You see this one is represented here, and then we have dimensionality. Next instruction for all threads is writing down the dimensionality of how many rows, or epsilon dimensionality, 18 times, and then we have what we have here. Yes, this dimension is given here. We have 18 ones, and probably because there is no this dimension, it didn't write anything. So yeah, it's not written. Maybe if I put here, let's put here 2 and see is something happening there. So we're expecting that we have 2 blocks in x-axis. Will be there some changes. Let's do this again. Okay, we compile it. Let's execute it. What happened? Yeah. Interesting. Yes, we are still in dimension. We are still just picking up x dimension. We define 2, and then we have, because we define 2, we have 2's here, 2 and 1 dimension. Why did it? But interesting thing is that this grid dimension is reduced in next iteration. I don't know why it's that like that. Because this shell represents the okay, sorry, that's the mistake. A little bit of troubleshooting. Let's save it again, and now we should maybe expect some 0 or something like that. Yep, let's compile it again, then execute. This was confusing. I didn't put the right thing here, so that was the source of mistake. And then ER2, okay. Yes, only one dimension in epsilon axis, this one, because we put here 2, and 2 dimensions as we expect, because we call it two blocks in a grid in x-axis. So x-axis, so it's obviously that this one, that this dimension is 2, and this one, which is normal, is fixed or 1. And let's try it again with the previous calling. Probably should be here 1 for both of them. So let's save it. Save. Okay, execute, and then going this way, and we, yes, now confusion is avoided. So 1 for x and 1 for epsilon dimension. So the source of mistake, it was x. X here I didn't put good writing, so I can recognize in a good way. So 1 times 1 was dimension if we put straightforward 1 here. But these mistakes and all this is actually to help you to use better these built-in variables, which are block indexes and thread indexes, x, y, and z axis. So I hope that with this example we are going to do good job for better understanding of usage of these indexes. So I hope this will help. So until next time, bye bye.